Logarithms Day 2. Our learning target today, I can expand logarithmic expressions using properties of logarithms. All right, so we've already seen our exponential form and our logarithmic form. This is a review from yesterday. Remember, the exponential form says b to the x equals y, and logarithmic form, log base b of y equals x. There's two kind of common or logs that we'll see fairly often that are called the common log and the natural log. Notice how common log doesn't have a base written. The common log, the base is always 10. So if you do not see a base written, assume it is base 10. The natural log is the same as log base e. So log base e is written as natural log. And e is a number you maybe heard about last year in Algebra 2. It is an irrational number. It goes on forever, kind of similar to pi. There's a button on your calculator that's a little lowercase e, and that's the button that you'll be using anytime that you see e, and it's approximately 2.718 maybe, so something like that, but make sure you're using that e button anytime you see the e letter. So a quick review here, it says write each equation in exponential form. So base to the number on the other side of the equals sign equals 3 here, and 16 to the 1/2 equals 4. Sorry, you can hear me try and get to the next slide. There we go. All right, so here, write each equation in logarithmic form. So log base 2 of the number on the other side of the equal sign equals the exponent. And in this example, log base 2, same base, of 1/8 equals -3, equals the exponent. And to evaluate, remember we set equal to x, we rewrite it, 2 to the x equals 32. 2 times itself, how many times equals 32? X equals 5. And for our other example, again, set equal to x. 5 to the x equals 1/625. So we know x must be negative because that's how we get the 1/. And 5 times itself, how many times will give us 625? X equals -4. So let's talk about some of the properties of logarithms. The next button doesn't seem to work. All right, properties of logarithms. As you see here, we have some of our exponent properties that we're also familiar with, and we're going to see how they relate to logarithms. So if we have x squared times x to the 3rd, we know that we would add those two exponents. So when we talk about our log properties, if you have log base b of something times something, again, we can separate them to be log base b of m plus log base b of n. So kind of same with the exponents, you would add the exponents. Here you would add two separate logs together. And division, we know that we would subtract our exponents. So similarly, we would subtract our logarithms. So log base b of m over n would be rewritten as log base b of m minus log base b of n. And for one final example, we have a power to a power. So we know if we have a power to a power, normally we would multiply those powers. This one gets a little bit different. Notice how what happens here is that power jumps all the way into the front and is multiplied. So it goes from being an exponent on the m to being in front. So it's like p times the log base b of m. And if we were to compare powers, we know if log base b of m equals log base b of n and the two bases are the same, then m must equal n. So let's do some examples here. This says expand each expression. So here we have log base 6 of 5x, and we know 5x is the same as 5 times x. So we can rewrite this as log base 6 of 5 plus log base 6 of x. So we're just using those properties to rewrite it. Another example, here we have the natural log of 7 over 10. We can rewrite that as the natural log of 7 minus the natural log of 10. And make sure you pay attention to the order. The numerator gets to be in the first half, and the denominator is what is being subtracted. Here we have log of x to the 5th power. So remember that 5 goes into the front, so we have 5 times log of x. And again, remember, if there's no base written like there isn't here, that is a log base 10. We're going to get into some bigger examples here. Log base 4 of x to the 5th times y. So we have two things being multiplied together and an exponent. We almost have to go in backwards PEMDAS. So we have to separate out our multiplication before we can move our exponent. We can't just move the exponent when we want to. So we're going to separate the multiplication first. So log base 4 of x to the 5th plus log base 4 of y. And then we can separate that first half, or that first piece, a little bit more by moving the 5 down. And the reason we have to separate our multiplication before we can move our exponent is if we move the 5 into the front and then we separate, you would probably want to move the 5 to both pieces, and the 5 only belongs on the piece with the x. So it's important to pay attention to which numbers belong to which variables. Try another one here. Log base 5 of 3x over y squared. We're going to start by separating this with the division. So we're going to start with log base 5 of 3x minus log base 5 of y squared, and then we can separate it even further. And remember, there's kind of like a parentheses here to keep each piece together, so we know we want to separate it with division first. Separate it again, we've got log base 5 of 3 plus log base 5 of x minus 2 log base 5 of y. Couple more examples that we'll look at. Here we have log base 6 of the cubed root of x over y to the 4th. Let's separate out the division first again. Remember, there's kind of a little parentheses here, and then we'll deal with exponents. So we have log base 6 of the cubed root of x minus log base 6 of y to the 4th. Remember that we can say this x to the cubed root of x is the same as x to the 1/3 power. That's important to know because remember exponents can come down into the front. So we can rewrite this as 1/3 log base 6 of x minus 4 log base 6 of y. We'll do one final example, and then I will send you on your way. This one is the natural log. Natural log of 5x cubed over y. Remember, we're going to keep that together while we separate the division. So natural log of 5x cubed minus the natural log of y. Then we can separate the multiplication. And I like to write my natural logs, or my L for my natural log, as kind of a cursive L so that I don't get it confused for a number 1, which can sometimes happen if you are having writing that you can't always read. So that's why I write my L's for natural log like that. All right, one more separate here. We've got natural log of 5 plus 3 natural log of x minus natural log of y. Your homework should be posted. You'll be practicing rewriting and expanding your logarithmic equations.